Hey, okay, let's begin chapter 8. Chapter 8 is on confidence intervals. So we are going to take our ideas of the normal distribution and even the more advanced version with the central limit theorem, and we're going to take our investigations to a whole nother level starting in chapter 8. So chapters 8, 9, 10, and you could say even chapter 11 plays into this a bit too. Um, we're going to turn from investigating, calculating probabilities to then what we call inferential statistics. So chapters 8, 9, and 10, and you could certainly argue chapter 11, are all part of this thing called inferential statistics, which will be a big part of your final project. You're going to analyze, you're going to do all the inferential statistics on that too. So, okay, so before we even get into chapter 8, there's some prerequisites to talk about, just some skills, and then one concept even that is gonna really put us on the right foot. So this first prereq you might be pretty familiar with, um, or maybe it's new, but it's good to see this ahead of time. Let's write in interval notation, and here I've just got a number line with some of the numbers shaded. So between -2 and +2, and I've got these parentheses there and there. So we're indicating the numbers between. What would that look like in interval notation? And here it is, right? So all we do is put those parentheses. We indicate where the numbers begin and where they stop. So where they start and where they stop. And so if someone's looking at this and they know it's interval notation, they'd say, okay, they're talking about all the values starting at -2 and ending at +2. But the parentheses tell us not the numbers themselves. And that's how we're going to use it with confidence intervals in a moment. Okay. How about maybe this one? This one's nice and symmetrical around 0. What's happening here? Well, let's identify where these occur. Looks like that's 0, 1, 2, 3, and 4. And so there it is, right? You might be really familiar with interval notation. Maybe you're not. This is all it means. When you look here, you say, oh, okay, so the values begin at 1 and they end at 4. It's all the numbers in the middle, but not the endpoints themselves. Not the 1 itself, not the 4 itself. Okay. And then the second idea here in the prereqs is actually comes from our formula for the central limit theorem back in chapter 7. Z equals x bar minus mu over sigma, which is over the square root of n. Okay, so here's what we're going to do, and I'll just show you the rest of it, but one part at a time. From here to here, what happened? Well, I could multiply this denominator over onto that side, right? The whole thing, z times sigma over the square root of n, and that would equal x bar minus mu. Like, okay, well, what's the big deal with that? X bar minus mu is telling you how far apart those are. How far is x bar away? How many units distance between them? Well, if it's equal to this, then that must describe how far apart these are, if I know that result. The distance from x bar to mu. I think a picture here is really helpful. This is drawn a bit light. All right, so if I've got my normal distribution, mu is at the center. Let's say somewhere up here is x bar, and I really want to know how far apart these are. When it comes to confidence intervals, this is key. Can I figure out how that distance? And hey, well, now I've got an easy way to compute that. The z-score that would go along with this x bar times sigma over the square root of n. Okay, so this formula is going to come back here in just a moment.